Hello and welcome to the short video ARM and Compliance. This is a talk that Jason McNutt and I presented at Ignite last week. Since the video of this talk was not available, we decided to record a short version to give you key messages from that talk. So Jason and I presented this talk. This talk was really about Azure Resource Manager and compliance. So what is compliance? It is complying to laws in this talk. Of course, we talk about things like PCI and FISMA, and FedRAMP, which are more US-based standards, but this process that we are going to talk about applies to any other standard that may apply to different parts of the world. It is a shared responsibility model where the provider can bring a number of controls that you can inherit as an application developer, but then you own the responsibility of securing your data and your application portion. So that's how it's a shared responsibility model. And this idea of compliance is enabled through this life cycle of secure DevOps that we're going to talk about next. So this slide essentially talks about the different stages of secure DevOps. And it starts with the first stop, which is about setting policies. So even before we provision any resources in Azure, the first thing we want to do is enforce some sort of policies. Which data center do you want your resource to reside in? Do you want them to be residing in a certain national boundary? What kind of encryption standards do you want? Those are the kinds of things that you want to set up early on in your secure DevOps process. That's the first stop. Once you've set the policies, then you can come in and provision or deploy resources. And this is where we will talk about a project that we worked on called the Azure Blueprint Project, which is about deploying these resources to be secure from the ground up. So once we have deployed the resources, that's not enough. We need to run a post-deployment validation script to make sure that the resources that we have deployed are indeed compliant with the standards that we want. The next step is the document or automated document generation. Oftentimes, compliance requires a set of documentation that your security team may be needing. So we talked about how by applying certain metadata in the form of ARM tags, and then being able to inspect these tags at runtime, and then being able to generate the documentation. And we'll be using third-party libraries, open source libraries, to automate the generation of these documents. And then finally, after you have deployed, after you have done the post-deployment validation, generated the documentation, your job is not quite done. At that point, still you need to be constantly monitoring your application, your provisioned resources, to make sure they continue to remain compliant. So this 5-step process is what we call a secure DevOps process, and is the only way we think to make sure your applications are compliant, not just at the design time, but at provisioning time, deployment time, and then of course continuously post-deployment. Let's talk about the first stage in the secure DevOps process, which is the resource policies. And I've highlighted the policies here. And here are some scenarios where policies would come into play. So we talked about some policies earlier, but policies could also be in the form of chargeback. When the resources are being provisioned, you want to make sure they have the right tags, the department tags. You can ensure geo-compliance. I talked about this example. We will talk about things like service catalog in a moment, but then you can also enforce things like naming. You want to make sure that the resources being provisioned have appropriate metadata associated with them. So the key concepts around policies are a default allow system. I think this is an important point to note there. And then policies are described through these JSON documents. I'll show you an example known as the policy definitions. And then they are assigned at different scopes using the policy assignment statement. So you define a policy, and then once you've defined this policy, you can apply it at a subscription scope or a resource group scope using a policy assignment statement. So here's an example of a policy definition language. So you can see the if operator, the conditional operators, and then you can have in the then clause of this policy definition language, you can either deny a resource from being provisioned. So if somebody is trying to deploy a resource which is outside of the geo boundary, you can either deny, or you can allow them to go ahead and deploy the resource, but write to the audit log. Or in some cases, if a critical metadata is missing, maybe you want to append that using that append clause. Some other aspects of the policy language definition here: do you want all the conditions to be met or one of the conditions to be met, etc. So this gives you a quick idea of the policy definition language. And once again, going back to our compliance secure DevOps lifecycle, we covered the first stage, which is setting the policies. Next, we want to talk about deploying securely from ground up. And this is where the project that I was talking about, the Azure Blueprint project that we worked in conjunction with the Azure teams. And you can find more information here, the GitHub at Applied IS there. And what we have done essentially is we have taken an entire application, and these templates right now apply to an IaaS configuration, and in future this same idea can be applied to PaaS as well. So what we have done is essentially taken an IaaS, classical IaaS architecture, and then overlaid on that security controls that apply to the FISMA controls. So in this architecture, you can see there are virtual machines, there are availability sets, and then we talk about how can you take this configuration and deploy that securely. And if I go further up, you can see there are a bunch of templates here that are available that talk about how you would be writing these templates so that they are compliant from ground up. To give you a more concrete example, let me just go to the wiki page of this GitHub repo. And here you can see, if I go further down, once again, the same architecture diagram here. And if we go further down, these are the NIST controls that I was talking about. And by defining the ARM templates in a manner that are compliant with these NIST controls, you can see the NIST controls have been categorized into authentication management and then key vault management. And if I click into key vault management, for example, it tells you how we have implemented these resources so that they can deploy it in a manner that is consistent with these NIST controls specifically. Okay, so you can once again take a look at this project, take a look at the various templates, and then in addition, all of the subparts of these templates have been provisioned as nested templates. So we can individually go call them if you wanted to just take parts of this template and apply it to your project. So here's the slide that talks about the specific controls that I was talking about in the previous demonstration. So this is the Nest SP 800-553, about 700 controls. 200 of them are process controls. And then 200 of these controls are inherited just by virtue of using Azure Gov. And these scripts are comprised of ARM templates. We have to write virtual machine extensions. In addition, some desired state configuration code as well that you can take a look and use in your projects. That brings us to stage 3. So we talked about policies, we talked about deployment. Let's talk about validation. So once you've provisioned this Azure Blueprint template, or maybe a subset of that, you would want to still run some sort of a validation script to make sure, let's say, that OMS agents are appropriately installed. And OMS is a key part of how we're able to achieve compliance. So you want to make sure that the OMS agents on these virtual machines are indeed installed and configured correctly. So you want to run some sort of port post-deployment script to make sure that is indeed the case. The next step that we want to talk about is the automatic document generation step. And I talked about earlier on that you could take advantage of tools like this, and let me bring another project here. This is the Open Control project. Right here, Open Control from Compliance Masonry. And the idea behind this project is that you have a bunch of YAML files, and then you can use this Compliance Masonry command line tool to generate certification documentation. So typically what you want to do is, and this is the part that has not been implemented, this is an area that we want to do more work in, is apply appropriate ARM tags to the resources, and then you can walk up to a configuration and then look at all of the metadata tags, transform them into YAML files, which that Compliance Masonry tool can take and generate the documentation for you automatically. So that's the automatic documentation generation part. The last and final stage in our secure DevOps lifecycle is the monitor stage. And as I said earlier, having these secure ARM templates are not enough. Post-validation is not enough. We want to continuously monitor these deployed configurations. And one of the approaches that we can use for continuous monitoring is a recent approach that was announced by the Azure team called Event Grid. In the case of validation, I was talking about how you needed to go through all the virtual machines and make sure the OMS agents were installed correctly and functioning correctly. But if you wanted a way for you to be notified, rather than having a pull model where you go through all of these resources and make sure they are valid, wouldn't it be better if you were notified of an underlying change in the infrastructure? And that's where the newly announced Event Grid comes into play. Think of Event Grid as a platform that is throwing events at you if some underlying infrastructure resource changes. So let's say I can publish my events related to blob storage to Event Grid, and then I can then subscribe an Azure function perhaps which will get executed when something changes in the infrastructure. So it's really a low-cost, scalable way of monitoring your infrastructure and then taking action. So if somebody went ahead and changed something in your blob storage location, Event Grid would publish that event, and maybe you have configured a webhook which points to an Azure function which will get invoked, and then inside that Azure function you could check if a certain attribute of that blob storage has changed. If it has indeed changed, then you can write to an audit log or send an email to someone for them to go take a look, because now that blob storage instance may not be compliant. So Event Grid allows you a very scalable way of ensuring that your systems are being continuously monitored. Okay, so with this, we have one last thing to talk about very quickly related to Service Catalog. And this is also a new capability in Azure. And this sort of goes hand in hand with the ARM templates concept that I talked about. So rather than just provisioning this application for a user in your organization, you can rely on a concept of a service catalog where you essentially create a managed application. So you package up your ARM templates and provide it the right set of permissions. So a central IT group can create a managed application. Once you go ahead and deploy this application, it will indeed get provisioned within your resource group or your subscription, but the central IT will retain the rights to operate this application. So this way, you can go ahead and consume this. It is still inside your subscription, your resource group, but a central IT group can manage it, apply patches, and apply compliance features or capabilities around that managed application. So that's something to also think about as part of your secure DevOps life cycle. So with this, we come to the end of very, very quick review. We didn't have time to run through all the demos, but if you are interested in talking to us about any of these, please contact us. Hope you found this useful. We strongly believe that a secure DevOps lifecycle is the only way essentially to making sure that your systems in the cloud are provisioned in a secure manner and being continuously monitored and kept secure. Thank you for watching. Please let us know if you have any questions. Thank you.